All right, so I think I'm recording. Let's take a look at these two equations. They're radical equations. They both contain square roots. So we want to isolate the square root and then square each side of the equation. So let's jump in and take a look at number 5. We have the square root of 2x plus 13. We want that term by itself. So we need to add x to each side. So and now to get rid of this radical, we need to square each side. And we need to recognize that when we do that, we introduce the possibility of extraneous solutions. So the solutions to 2x plus 13 equaling x squared plus 14x plus 49 may not be the same solution set to the original equation. This equation, they'll be the same solution set, except this second one here, this new one, this quadratic, may contain extra solutions. All right, so let's get this equal to 0 so that we can either apply the completing the square or quadratic formula or hopefully factor it. So we've got this x squared term, and if we take 2x away from each side, we'll have 12x over here. If we take away 13 from each side, we'll have 36 here. And so this factors to x plus 6 quantity squared. And this is giving us a possible solution of negative 6. So let's plug that into the original equation and see if it does belong to our solution set or not. It's our only candidate. So when we substitute in on the left-hand side, we have 2 times x, which is negative 6, plus 13 minus a negative 6. And the big question is that equal to 7? Well, 2 times negative 6 is negative 12, and negative 12 plus 13 is 1, and the square root of 1 is 1. This double negative here changes that to addition. 1 plus 6 is equal to 7. So this is in our solution set, and we're done with this problem. Let's take a look at this next one. We need to get the radical by itself. So I'm going to add the square root of 2x plus 5. No. Well, what I do is when a term changes sides, it changes sign. So I look at this and I say, hey, I want to switch places with those two. I want to have x minus 5, and I want to have the square root of 2x plus 5 here. So, you can pause the video and justify that I've added the square root of 2x plus 5 to both sides of the equation, and I've also subtracted 5 all in one step. All right, so I'm going to square the left-hand side and square the right-hand side. So on the left-hand side, remember that exponents do not distribute. So I get x squared minus 10x plus 25. On the right-hand side, this radical has now gone away. So I can come in and get this in standard form by subtracting 2x from each side, by subtracting 5 from each side. And now I want to try and see if I can factor this. Now, two numbers that multiply together to give me 20 but add together to give me a negative 12, I don't see it. Oh, yeah, I do. Negative 2 times 10 is 20. So I don't know why I didn't see it. I'm not very good at mental arithmetic, and sometimes it's embarrassing that I don't see something quicker than what I do. Negative 2 times a negative 10 is positive 20, but yet when I add these together, I get negative 12. So I have possible solutions here of x equals 2 and x equals 10. but I need to check those to make sure that neither one of those is extraneous. All right, so when we check x equals 2, on the left-hand side, we have 2 minus the square root of 2 times 2 plus 5. And the big question is, when we do that arithmetic, will that equal 5? So 2 times 2 is 4, and 4 plus 5 is 9, and the square root of 9 is 3. And 2 minus 3 is not equal to 5. So x equals 2 is an extraneous solution. It was a solution to this quadratic equation, but when we squared both sides of this equation, that x equals 2 was introduced to this equation, and it's not a solution to our original equation. All right, so let's check 10 and see if it, I'm just going to erase this. I don't need this anymore. Let's plug in 10 and check and see if the left-hand side is equal to the right-hand side. So when I plug in 10, on the left-hand side, I have 10 minus the square root of 2 times 10 plus 5. And the big question is will that arithmetic equal 5? The right-hand side of this equation. All right, so 2 times 10 is 20, and 20 plus 5 is 25, and the square root of 25 is 5. And yes, it's true that 10 minus 5 is equal to 5, so this is in our solution set. All right, so hey, I hope that helps. I'll talk to you later. Don't be afraid to ask questions. Bye.